Hi sir, this is Joshna from Tribly Department, roll number 228. Today my topic is mean value theorem. Introduction of mean value theorem. The mean value theorem is a key result in calculus that shows the connection between the average rate of change and the instantaneous rate of change of a function. If a function is continuous of a comma b and differentiable on a comma b, then there is at least one point inside the interval where the derivative equals the average slope of the function over the interval. Statement of mean value theorem. If a function f of x is continuous on the closed interval a comma b and differentiable on the open interval a comma b, then there exists at least one point c in a comma b such that this means that at some point c the instantaneous rate of change derivative of the function equals the average rate of change of the function over the interval. Mean value theorem of 5 types: Rolle's theorem, Lagrange's mean value theorem, Cauchy's theorem, Taylor's theorem, Maclaurin's theorem. Rolle's theorem. Rolle's theorem states that if a function f of x is continuous on the closed interval a comma b, differentiable on the open interval a comma b, and f of a is equals to f of b, then there is at least one point c in a comma b such that f dash of c is equals to 0. This means that curve has a horizontal tangent that slope at some point inside the interval. Example, let f of x is equals to x square minus 4x plus 3 on 1 comma 3. F of 1 is equals to 0 and f of 3 is equals to 0. So f of a is equals to f of b. The function is continuous and differentiable. F dash of x is equals to 2x minus 4. Setting f dash of c is equals to 0, 2c minus 4 is equals to 0, c is equals to 0. So at x is equals to 2, the slope is 0, satisfying the Rolle's theorem interval. Lagrange's mean value theorem. Lagrange's mean value theorem states that if a function f of x is continuous on the closed interval a comma b and differentiable on the open interval a comma b, then there exists at least one point c in a comma b such that f dash of c is equals to f of b minus f of a by b minus a. This means that at some point the instantaneous rate of change equals the average rate of change over the interval. Example, let f of x is equals to x square on 1 comma 3. Average rate of change f of 3 minus f of 1 by 3 minus 1 is equals to 9 minus 1 by 2 is equals to 4. So at x is equals to 2, the instantaneous slope equals the average slope, satisfying Lagrange's mean value theorem. Cauchy's mean value theorem. Cauchy's mean value theorem is general form of the mean value theorem. If two functions f of x and g of x are continuous on a comma b and differentiable on a comma b, then there exists a point c in a comma b such that f dash of c by g dash of c is equals to f of b minus f of a by g of b minus g of a. Example, let f of x is equals to x square and g of x is equals to x plus 1 on 1 comma 3. F of 3 minus f of 1 is equals to 9 minus 1 is equals to 8. G of 3 minus g of 1 is equals to 4 minus 2 is equals to 2. So f of b minus f of a by g of b minus g of a is equals to 8 by 2 is equals to 4. Now f of x is equals to 2x, g of x is equals to 1. We want f dash of c by g dash of c is equals to 4. 2c by 1 is equals to 4 is to c is equals to 2. So Cauchy's theorem is satisfied at c is equals to 2. Taylor's theorem. Taylor's theorem states that a smooth function can be approximated near a point by a polynomial whose terms come from the function's derivatives. At the point, it gives a powerful way to approximate complicated functions using simpler polynomials. Formula: f of x is equals to f of a plus f dash of a into x minus a plus f dash of a by 2 factorial into x minus a whole square. Example, approximate e power x near x is equals to 0. e power x is equals to 1 plus x square by 2 factorial plus x cube by 3 factorial. So for small x, e power x is equals to 1 plus x square by 2. Maclaurin's theorem. Maclaurin's theorem is a special case of Thales theorem where the expansion of a function f of x is done about x is equals to 0. It expresses a function as an infinity power series in terms of its derivatives at 0. F of x is equals to f of 0 plus f dash of 0 plus x square by 2 factorial f dash of 0 plus x cube by 3 factorial f dash of 0 plus. Example, expand e power x using Maclaurin's theorem. F of 0 is equals to 1 comma f of 0 is equals to 1, f dash of 0 is equals to 1. So e power x is equals to 1 plus x square by 2 factorial plus x cube by 3 factorial. Conclusion, the mean value theorem connects the average rate of change of function to instantaneous rate of change if a function is continuous on a comma b and differentiable on a comma b, then a point c always exists where the derivative equals the average slope. It shows the smooth curves cannot jump or skip slopes between endpoints. It helps is understanding function behavior, and it is widely used proving inequalities and properties of functions. Thank you.